So today we want to move on to, now we are done with the structured programming. We have done operators, control structures, and also functions. Okay. So we combine these things, we can now solve problems. Uh, but there's another way of solving problems or another way of programming, that is object-oriented programming. For simple problem solving, structured programming is good enough. But when it comes to developing complex systems, especially big systems with a lot of functionalities, these days we mostly use object-oriented programming. Okay, object-oriented programming. So let's move on to object-oriented programming. So this is the idea behind structured programming. Okay. So basically we have data, we process into information, that is our output. How, how do you represent your data? Using variables. That is why we have variables. And how do you process? Right? We process using applying operators or operations with the help of control structures. Sometimes we apply conditionally, we apply operators. Sometimes we repetitively apply operations. And of course, we don't apply just one operator, set of operators, sequentially, selectively, iteratively. So that is one way of programming. So what is the second approach? Object-oriented programming, software development. So this approach is better for complex systems, big systems, system where we need to reuse rather than we write everything, like using frameworks and so on. And we want to use our own things also. Anyway, here also we can do reusing by using functions. So the same function we can call it later also. Right? You write one function and you can call it many times. So that is also reusable. But in object orientation, there are so many other ways of reusability. Okay? So earlier we had a little bit more about object oriented in A-level ICT, but they have removed a lot of stuff and just kept a very gentle introduction. Right? So that is normal because understanding object-oriented programming is a little bit more complex. Of course, it is not impossible. Anyone can perfectly understand, but you need a bit of experience, exposure, maturity to fully understand object-oriented concepts, and also it's a little bit big area as well. So therefore, what we are going to do is, anyway, your A-level ICT exam question is structured programming, right? Don't think that we are going to get object-oriented programming question for second paper. No. So just concentrate on structured programming, but little bit idea about object-oriented. Okay. So why little bit of idea about object-oriented? Because now we are going to do file handling, database handling. Okay. For that kind of situations, even Python language itself use object-oriented concepts. For example, file object. In collections, we use objects notation. So therefore, rather than we learn how to develop software using object-oriented concepts, we need to have the basic idea so that we can use those object-oriented concepts or objects built into the Python language. Because Python language itself also has some functionalities presented as objects. Okay, so therefore we will learn object-oriented concepts to use it existing features rather than we write object-oriented code. Okay, so that is the idea. And also when we use object-oriented programming or do programming, we don't replace structured, right? It's complement structured programming. So that means our big picture is object-oriented, but still inside we heavily use structured programming. So that means we can mix it bit of object-oriented inside structured, and structured programming inside object-oriented. What we learn is, at the end, use of object-oriented programming inside structured programming. Okay, not doing object-oriented programming and use structured inside. No, but when we learn, yes, we learn bit of like that. Okay, right. So what is the idea behind? Now I have already explained. Of course, we have been doing this. What is the idea behind structured programming? So we represent our data in variables and process using applying operators with the help of control structures to get our results or the information. Right. So similarly, what is the idea behind object-oriented programming? If you are designing the software using object-oriented manner, right? So the idea is we model the system as, so we look at the system as set of objects communicating and collaborating. So that is a different way of thinking. Okay. So you look at the system, maybe it's order processing system, inventory management system, okay, uh, accounting system. So whatever the system, we look at it as set of objects, order objects, payment objects, okay, customer objects. So it's a different way of thinking. Right? And at the runtime, these objects communicate and collaborate. Communicate, collaborate means one object can call the behavior of another object to get something done. So then that object can get call behavior of another object. So likewise, it's a collaboration. So these collaborations of objects does the required operation. Maybe that operation is creating a new order, doing a payment, money transfer. So that is the idea behind object-oriented programming, object-oriented design and programming. Okay. So what is object-oriented programming? If someone asks, we look at the system as set of objects, communicate and collaborate to perform the system functionalities or achieve the objectives. Here, we represent our data in variables and process using applying operations with the help of control structures to get the required result or the information. So you must know the two definition, not just memorize, understand as well. Okay. So this you need to understand 100%. This you need to have the basic understanding because we don't go into details. Okay. So we have been doing structured programming for not last 4-5 weeks, I think. But here, object oriented, we are going to finish it today itself. Okay. Because we are not going into the details. Right. So this is a formal definition again. We model and design the system as set of objects. That is why we call it object-oriented programming that communicate and collaborate in order to achieve the common objective of the system. Okay. So at the end, the functionality must be done. Objectives are achieved. Objective can be managing the accounts, managing orders and payments, managing students' marks. Okay, different systems. Okay. Right. What are the advantages if you use object-oriented approach? So the code will be more modular. You can look at the code as set of components, modules. In structured programming, those were called functions. In object-oriented programming, these modules are components, are objects, or rather we can call it classes later. So different functionalities are encapsulated into different classes and objects. Class is another word for objects. Slightly two different meanings, but highly related. So order related functionalities in order class, payment related functionalities in payment class, customer related functionalities in customer class, and so on. So we divide the functionalities, which is very important when you solve big problems, complex problems. So that is called divide and conquer. Right? Top-down decomposition. We discussed that under design. Okay. So yes, order management system is a big system, but we've divided it into order related functionalities, payment related functionalities, customer handling, like registering new customer. So then these are reusable components. So we can concentrate on different classes, but at the end they must collaborate and communicate. So the code is more modular into classes and easy to handle complexity because we can concentrate on different functionalities are encapsulated into different classes. Okay. And the other thing is we can reuse and easy to maintain because these are modular. So we can reuse some of these classes in another system. Okay. And easy to change because one place we have one set of features, customer related features in one class, order related features in another class, rather than mixing this in a sort of big program. Okay. So that is the idea. Right. So then what are the disadvantages? Because we need to look at both sides of the coin. So it's not really disadvantage, but bit of a challenge. That is, uh, understanding structured programming is easy. Even a kid, you know that in these days, even grade 5, 6, 7, kids start coding. What they learn is structured programming because even a kid can understand what is operation, what is a control structure, what is if else. But object-oriented programming is not for kids. Right? It's little bit more complex to understand. So that is why even in A level ICT, you have just a basic overview of object-oriented programming. So that is the biggest disadvantage or the challenge. So you need to learn these concepts patiently, understand, get the confidence, and then you can design and develop systems using object-oriented concepts. That is why I told you object-oriented programming is not for kids, for serious, matured software developers. Of course, now you are in that kind of a transition, right? You are in the advanced level. Maybe your next education is professional education, right? Doing a IT degree, doing an engineering degree, or something business. So therefore, yes, at that level, you will further learn object-oriented software development because I told you this is not for kids. And you guys are neither kids nor adults these days. So you are the intermediary transition time. So therefore, yes, it's a good time to learn basics of object-oriented programming. Okay. Right. So when to use object-oriented programming, as I told you, when you are developing more complex, big system where you want to reuse your code, you must you are thinking of ease of maintaining the code, changes, adding more features easily. For that kind of a situation, object-oriented programming is better than structured programming. As long as you have the developers, programmers who know object-oriented programming. And there are a lot of reusability in object-oriented programming. There are frameworks, right? Reusable code libraries, which you can easily reuse when you are using object-oriented programming. But it's very difficult to use those things, reuse those already available features when you're using structured programming. Actually, that is one reason why even Python uh, present file handling, database handling using object-oriented concepts so that we can easily reuse those built-in functionalities. So when someone develop a functionality using object-oriented concept, it's easier for others to use it, reuse it. Okay. And when even your code can be easily used by another system. Right? But the cost is, yes, you need to model it, design it little bit in more sophisticated manner. So therefore, when your system is complex, require long-term maintainability, reusability, go for object-oriented programming. Okay. Otherwise, structured programming is good enough. So this is what I mentioned. In A-level ICT, we mostly use object-oriented functionalities rather than we develop object-oriented systems. So, okay. So don't think that we are going to develop software using object-oriented manner. No. We just learn the basic concept so that we can use object-oriented libraries, features in our structured programming. Okay. So in that case, basically, we are not going to learn object-oriented programming at very serious level. Okay. Right. So anyway, we need to understand the basics so that we can use object-oriented concepts. So these are the basics in object-oriented. So if someone want to learn object-oriented programming, whether you are in A-level or university degree level professional education, so first of all, you need to understand these concepts, the basics. So then you can learn some other advanced concepts, right? Right. So advanced concept we are not going to look at all. Okay. So if I mention what are those advanced concepts like inheritance, polymorphism, those are advanced concepts which we are not much interested. Okay. But we are looking at the basics, the ABC of object-oriented programming. Okay. Right. So first one is object. Actually, object and classes are highly related. You need to understand together. Okay. Right. What is mean by object in object-oriented programming? Okay. So the word object is part of this approach as well, right? Object-oriented programming, object-oriented design, object-oriented analysis. So in object-oriented programming, object-oriented software development, an object is anything, or remember we discussed about entities in database, ER, entity relationships. So student is an entity, course is an entity. There's a relationship between student and course. And remember the name of the student, email of the student, those are the data, attributes of the entity. So I told you it's very important to understand the difference between entity and attribute. Attribute is a property of an entity. So then these entities are interrelated. Student study for a course. Student has done payment for a particular course. So this payment is for that order. So this employee working for that department. This employee working for these projects. That is entity. So then what is an object? Object is like an entity instance. A particular student, Nimal. So in database terminology, it's a record or tuple. Right? Student object, payment object, course object, order object. So it's like a order record. Okay? Student record. Object is like that. Right? So object is not an entity. So the concept of entity is related to the class. Okay, so you need to map out the database subject and programming subject. So remember, an entity can be living physical thing, non-living physical thing, or conceptual thing. Like employee, living physical thing, vehicle, non-living physical thing, bank account, order, payment. So same concept. In databases, we call it entity. In object-oriented programming, right, you call it object. Or actually, uh, in databases, you can call this entity instance because entity is called class. Okay. So therefore, object can be anything that you are interested, but it is not data. It's a major concept like customer, order, but of instance of that is called object. Okay. So then what are we interested about objects or later classes? Attributes and behaviors. So this is the difference between database subject and object-oriented programming. So in database subject, we were interested only about the attributes of the entity, not behaviors. But in object-oriented programming, a class or object, we are interested in two things: attributes, behaviors. Right? Say student, student ID, student name, student date of birth, attributes, student behavior, student attending a class, student sitting for exam. Those are the behaviors. Okay, so now you need to understand both attributes and behaviors, because earlier behaviors were part of your structured program, but now we are going to break it into, okay, this is a behavior of a student, this is the behavior of a course, this is the behavior of a teacher. So that is what is my break it into parts, not only the data and logic, both we break it into small components. And these components communicate and collaborate. So likewise, you need to gradually understand this. Okay. So attribute or properties, we are interested, like name, balance of a bank account. And then we are interested about the behavior of the object, and later we call it class. For example, if you take vehicle, so let's say conceptual example, easy to understand like a story. So what are the attributes of a vehicle object? Vehicle number, vehicle color, vehicle brand, maybe mileage, what is the current fuel capacity, current fuel level. So those are the attributes. But at the same time, you can think of there are behaviors for this vehicle. Start, accelerate. That is why you have keyhole, right? Push button to start your vehicle. Stop, right? Brake, accelerate, switch on wiper, turn left, turn right. Those are the behaviors, right? Those are the behaviors. So that is for a physical object. And you can think of the same similarly for conceptual objects. Say bank account, right? Bank account. So the bank account, the behavior can be deposit money. You may think that is a behavior of a customer. No, customer just call it. Just like driver just call the start behavior. Start behavior is not a behavior of a driver. Driver just call it. Start behavior is part of the vehicle. Okay. Accelerate is a behavior of vehicle. That is why there's interface and accelerator pedal. It's a behavior of the vehicle, not driver. So likewise, every class has set of attribute behaviors. If it is a bank account, like conceptual object or class, account number, balance. So those are the attributes. Behaviors are deposit, withdraw, add interest. Those are the behaviors of the account, not the behaviors of the customer. Okay. Because in the exams, they can ask this kind of a simple question, right? Which of these are the behaviors of a particular class? Which one is the correct one? So far, they have not asked a single question for the last 5 years about object-oriented programming. But you need to use object-oriented concepts when you handle file handling, database, and open. Those things are part of your past paper questions. I mean, they have not purely asked what is object-oriented related concepts, okay? But maybe in the future, because this is indirectly mentioned in your syllabus. Right. So now I explain what is an object and what are we interested about objects, the attributes and behaviors. Right? Attributes of the object, behaviors of object. And in a system, there can be so many account objects, so many student objects, because object is like a record or tuple of an entity. Right? So particular school can have thousands of students. A particular bank can have thousands and thousands of accounts. So therefore, rather than understanding or modeling these individual or instances or the individual students, individual accounts, individual payments, individual orders, we need a way to model it. To represent all the orders, we model order class. To represent all the payments, instances, we model payment class. To represent all the account objects or the instances, we model account class. To represent all the customer objects, we model a customer class. So that is where the word class comes. So I told you class and objects are highly related because what is the definition of a class? Class models set of similar objects. Right? So yes, we are interested in student object, but there are thousands of students. To represent all these student objects, we model student class. Right? To represent all the courses, course objects, we model course class. So therefore, what is a class? A class represents or models the objects of the same type or objects of that type. And if you have class A represent all the objects of A type. So if you have class or order, it represent all the order objects, possible order objects in the future also. Say customer go and add a order or maybe online. That means you are creating another object. Okay. Say you go to the on-site uh, online e-commerce site and order something online. So there's a order object created in the system. And that order instance will be related to order class, and order class will be related to order table in the database. So that is how you connect database and programming. Okay. Right. So therefore, what is a class? Class represents or models objects of same type or objects of that type. Like class A represent all the A objects, A type objects. And remember, we are interested in attributes and behaviors of object. So therefore, what do we need to model in a class? Attributes and behaviors of that class. Right? Attributes and behaviors of that class. Okay. So sometimes we use two words when we explain objects, objects and classes. One thing is the word blueprint. Blueprint is like a carbon paper. Sometimes we use the word factory. Both are correct. So therefore, your class act like a blueprint for all the objects, right? And also your class act like a factory for all the objects of that type. So you know that when you have a blueprint and when you write something, there are copies everywhere, right? So your copies are like objects. And in a factory, we can create objects, right? If you have car factory, car manufacturing factory, so you release cars. So your car factory is like a car class. And these individual cars are like your car objects. Okay. So if you take a restaurant, there's a class called, say, biryani. Each and every biryani that is served is object. But there's a class called biryani. There's a class called fried rice. There's a class called pizza. And each and every pizza is instance. So that is how you understand. In a bank, there's a class called account. And when someone open an account, there's object, account object. Right? Okay. So you must know the connection and the difference between class and object. So therefore, class models attributes and behaviors of the its say objects. Okay, objects. So because this is a software development method, software developers has come up with some conventions, designing models or the designing ways because you need to model it and then develop the software. So upfront, there's more work. You can't just straight away start coding like in structured programming. Structured programming easy to start and start coding, but when things are getting more and more complicated, you stop. Object oriented, initially there's a additional work. Think about it, model it, but later it's easy. Maintainability is high, reusability is high. So upfront investment. Later you get the dividends. Structured, no upfront investment, but later you may struggle if it is a big and complex system. Okay, so therefore, when you start learning object-oriented programming, sometimes you get frustrated. Why do you want to do this kind of big things to get simple things done? Yes, yes, I know. But this really pay off when you are developing a banking system, inventory management system, and so on. Okay. Right, so just give me 1 minute. Just give me 1 minute. Right, sorry for that. Right. So therefore, you need to do a bit of modeling. Right? It's not rocket science, but identify what are your classes, what are the attributes and behaviors of those classes, and so on. Okay. So let's take an example. Let's say employee class. That is very easy to understand because we all know what is an employee is. So now we need to identify what are the attributes that we are interested in the system. So remember, we model only things we are interested. And we don't know, we don't care about whether what is his hair color. No, we don't care. But related to our, say, company, yes, we are interested in employee number, date of birth, maybe what is the post, what is the salary. Now, those are attributes. Anyway, we discuss these things on database as well, right? In databases, we call them attributes and later became fields. Okay. So that is attributes of a class. Okay. Or you can think attributes of an object, the employee object. So the next thing is you need to understand or model, identify the behaviors. Okay. So what are the behaviors of employee which is related to our employee management system? Maybe we are interested in the attendance of the employee, leaves, salary related things, OT related things. We are only interested in that kind of behaviors, which are related to managing employees. Maybe this is HR management system. Maybe appoint. So that is appoint an employee to the organization. Check in, check out, daily check in time, check out time. So that is why there are fingerprinting scanners and so on because we are interested tracking those whether a particular employee attended for a particular day's work or whether there's an overtime, promotions, terminate, transfer. Because when the employee moves from one department to the other, one post to the other, then salary might increase. So likewise, you need to identify the attributes and behaviors, right? Attributes and behaviors. So in database subject, we only interested in attributes, but in object-oriented programming, we are interested in both attributes and behaviors. Okay. So that means we need to worry about the attributes in the programming level as well as database level. So then there's a connection. Okay. So this is another example, a car class. Okay. Say registration number, model, color, fuel current fuel capacity. current mileage. So those are the attributes of a car. As I already mentioned, maybe start, stop, turn, accelerate, brake. Those are the behaviors. Anyway, this is just more conceptual story-like example, right? But this is more practical. But if you, for example, you know that we have computer games. So computer games is also software. Programmers have developed it. So there we have car classes. If it is a car race or something like that. So different car objects are created with different attributes, different color, different model. And when the player, computer game player interact with joysticks, mouse, keyboards, basically he or she is calling these behaviors. That is how the software is developed. That actually, so game development, we almost 100% depends on object-oriented program. Okay. So this is another example, because remember conceptual things can also be class. So this is a bank account. Account number, account type, interest rate, balance. Okay. Those are possible attributes. And these are some behaviors, possible behaviors. Of course, these are the behaviors of account. Because when you have a account, say savings account, you can deposit money. You can deposit money because account has that behavior. Bank has provided that behavior. Withdraw. A bank will call add interest at the end of each month. Okay, right. So I told you we are not going to do serious object-oriented programming, but you need to understand the concepts. And now we'll do just a tiny, simple example, and that's it. Because we are not going to learn advanced concepts, okay, to great extent. Right. So let's take account class because account class is more practical example than car. Of course, car is a practical example if you are doing game development or employee. Okay. So let's take bank account or account. So likewise, you have customer class, account class, loan class. Okay. So you will have that kind of objects, classes in a banking system. Right, banking system, and there can be special type of accounts. That is where the inheritance come. Right, your account can be savings account, credit card account, loan account. And that is those are the advanced concept: inheritance, polymorphism. So let's concentrate on object and class only. Right, this is a very simple example of an account class. Okay, account class. So how do you model it? This is how you could code it, right? In Python, class account and colon. So now you know that then it will be tab out, and inside that, as long as you have tab it, you are in the account class. Okay. So then your account class can have attributes like account number, balance, right? And behaviors like deposit, withdraw, add interest. Okay. So that is what your task. And once you have account class, remember I told you account is like a blueprint. Sorry, class is like a blueprint or factory where you can create objects. Now I have the factory. Once you code your account class, now you can create objects. So this is how you create object, account object. This is another account object. You can create account object. Right? So don't think that account object is created when some customer go and start account. Okay, that is just one place where account object is created. Now, there's a difference between the object-oriented concept of account and the real world account. Okay. there are a lot of similarities and there are small differences. So we usually when we say we create account, it's one time, right? We just create account, go to the bank or online, we create account. But in object-oriented software development, every time a particular customer interact with the banking system through ATM or from your online banking, account object is created, right? So I told you this is little bit hard to understand at initially. That is why this is not seriously in your syllabus, right? For example, you go to the ATM machine and insert your card, ATM card, which is released for your account, right? When you create account, they give you debit card. Now, when you insert the card and enter the correct username password, an account object is created in the memory, in the server, bank's web server or application server. So then that object interact with other objects to do the help you do the transaction, doing validations and so on. And that object communicate with your database tables as well to do the update of the your balance and so on. And then when you say you are done, yes, right, it will ask, do you want to perform any other transactions? No. So then it will, if there are any data to be saved into the database, it will be saved. And then the data object is removed from the memory. And of course, you get the card. When you get the card, the object created in the server is no longer there. And maybe again, if you insert your card, again the object is created. So therefore, when system is being used by users, these objects are created and destroyed. And these objects interact with the database and do the for processing. So that is the idea. Okay, that is the idea. Same for inventory management system. Whenever you a particular customer, any customer create a new order object is created. And then when the customer log off, that order object is no longer there. It's synchronized with the database. It's job done and then the object is not destroyed. So that is how object-oriented programming happens at runtime. Okay. So therefore, when you code this, it doesn't mean in the pro computer where the software or this Python class is, there's account object. No. So when you run, this is hard coded way. Of course, these things happen when someone enter into the log into the system or ATM. Okay. So then these objects are created. Of course, this is just demonstration, right? This is not real world scenario. We have hard coded account object and set some attributes like for balance and account number. These things we don't hard code. They are, it will be read from your card number. Right? You don't need to tell your account number, right? Because when you insert your card, it can get it from the database because your card has connected to your account. Right? Then when particular customer shows some behaviors and it asks to withdraw some money, then these methods are internally called depending on your data. And then the database is updated and so on. Now your transaction is reflected in the system. And then your attribute will be updated because this is synchronized with your table also later, but here we don't interact with the database. This is only during the memory, this session. This is not going to be permanent because we are not going to work with database or file. Okay. But this is the ABC of object-oriented or the idea behind object-oriented programming. Okay. Right. Again, don't try to understand this perfectly, but just try to understand the basics. Okay. Right. So let's take our IntelliJ, PyCharm. You can use even ideally perfectly, but PyCharm is for whatever you use, visual code or whatever. Right. So I gave you the last time's code, right? Yes. So let me delete these files. Those are related to the last class. Right. So let's create a new Python file. It's just a Python file. Your class is a Python file, .py file. We'll call it here. Usually for each class, we create one Python file, but here we create the class as well as the testing code in the same file. Okay, for simplicity. I'll call it account demo. Right. So now you can create your class just like this is just like any other Python file. Okay. But rather than writing the processing, the code, okay, the processing the code like structured programming, we are just going to model the functionality of a particular class, and let's call it account. So let's call it class. It's a keyword, just like print, if, while, okay, say account. By as a convention, usually we start class names with capital. It's not a rule. It's a good convention software developers mostly use. Okay, account. So then you have the colon. So then all your code will be inside this account class. Now, how do you model your attributes? Remember, account can have account number, a balance, because each account will have different account number, different balance. Okay. So how do you do that? There's something called constructor. This is called a constructor. This is called when a new object is created, this particular function. For example, when this object is created, this will be called. When another object is created, every time object is created, this is automatically called. So therefore, we call it constructor. Remember, it's like a factory. So therefore, whenever object is created, this special function is called. So remember, this is just a function, right? That is why we said def. But it must have a special name. Then only it is identified as a constructor or automatically called at object creation. The name must be underscore underscore init underscore underscore. And it must have first parameter as self and any other parameters you want, or just the self parameter only. But minimum, you must have the self parameter, otherwise it will be useless. So self means you are referring to your own self. Okay, right. So let's write this function def. So it's optional to have this function, but if you have attributes, always you need to have this. Okay, or rather later also you can add your attributes, but this is the best practice. Right. Def, it means just a function, underscore underscore init and underscore underscore. So that is your function. Okay. So there at least you must have the self parameter. Otherwise it's useless. Then other than that, you can have your parameters. If you are planning to give those values late when at object creation, you better have those as parameters. So let's say we have account number, ACCT num, okay, or you can have balance and so on. Usually you don't have balance at object creation, but at the when I create object, so usually you know that you need to have account number, right? So that is why I just add it, or anything else. So now inside this constructor, okay, you can refer to your attributes. You can refer to your attributes. How do you refer to them? you must dot use self dot. This dot notation is heavily used in object orientation. Okay, self dot. So in this case, I will call self dot account number and self dot balance. Okay, right. So I call it self dot. You can introduce any attribute here. I will say ACCT num, which I will assign to ACCT num, right? ACCT num. So that means I have an attribute called ACCT num. That value will be whatever you provide at the object creation time. This can be any name, even XYZ. This is your attribute name. Okay. So usually we use the same name, but it's not a must. Okay. Right. So that is, I have an attribute. And maybe I can have another attribute, let's say self dot balance. I'm just modeling the minimum, which I have not given as a parameter. So therefore, maybe we can hard code it to zero. Hard code it to zero. But later, maybe you can contact the database and get the balance and initialize once database functionality is implemented. But we are not interested in database here. Right. So now I have a constructor. Now this is called what? Constructor. It's a function with special name underscore underscore init underscore underscore, and you can have parameters, including self. Okay. Right. So that is a constructor. So then you can have any other methods, behaviors. In this case, let's say we are interested in deposit behavior, withdraw behavior. So those are just other definitions. So functions, say deposit. So then you must say how much you deposit, right? How much you deposit. So therefore, again, you can have self as attribute because if you are referring to your attributes, parameter, if you are referring to attributes, and any other things you want to send, because when you deposit something, you must tell how much you deposit, right? I will say amount. Now you can write your code self dot balance equal. Now to your current balance, you need to add amount. Okay. Or you can say plus equal. That means self dot balance equal self dot balance plus amount. Or you can say self dot balance equal self dot balance plus amount, whatever way you like. Amount. So that is okay. You don't need semicolon in Python, right? Sorry for that. It's for Java and other languages. Right. So that's it. So that is how you deposit, right? When you deposit money, that amount will be added to the balance. So this is a behavior. So let's have the withdraw behavior as well. Let's call it withdraw. Okay. So that means this is minus amount. Now this is a very simple, very minimal class. This account class. Now you can create objects in a different file also, but for simplicity, I will create the objects in here also. Now how do you, now from this point onwards, it's our normal code. Usually this will go into a different uh, Python file. Right, so just give it 1 minute, okay? Okay, sorry for that. So now we have the class. Okay, now we have the class. Now we can create objects. How to create objects in Python, right? So you can just call the class name, and if you have parameters other than self, you can provide the data and give it a variable name. This is like a account variable. You can have multiple account objects, just like XY variables. But these are objects now. Then use the dot notation to set these values. Or you can straight away use the constructor. Here account number I can set, but balance if you want, you can use the dot notation because or else you could have set it there. Okay, right. So let's do it. Say let's call it A1 or X or Y or whatever equal account because I have one parameter because this is default parameter. You can give your account number. Let's say 001, say AC001, okay, string. So then this will be executed and your account number will be set. Your account number will be set as AC001 and the balance will be initialized to 0. Okay. So then let's say when the particular customer or the account holder deposit money, uh, then deposit method will be called. How to do that? A1 dot deposit, and you can tell how much. This is implicit parameter. I will say deposit 10,000 because still my balance is 0. So similarly, you can create other objects as well. You can create other objects as well. Say I will call it A2. I'll give it different. Remember, give it a different name. Maybe now I'm doing deposit for, but this is hard coded. Okay, just to demonstrate. Say 50,000. Now let's print the account number of A1 and its balance. Okay, right? A1's account number and its balance. Right. So A1's account number is A1 dot ACCT now. Okay, comma. Maybe I'll have something like this just to show it. And then the balance. A1 dot balance. And I will do this similar thing for A2 object as well. Now A2 object's account number must be AC002 A2. Its balance must be 50,000 because these are separate objects in the memory. Right, so let's run and see. And you can see A1 10,000, A2 50,000. Yes, A1 we have deposit 10,000, A2 we have deposit 50,000. Now let's do withdraw behavior also. Now these are separate objects. These are separate objects. Say withdraw behavior, withdraw. Let's say we withdraw 2,000 here. Here we withdraw 5,000. So remember 10,000 deposit, 2,000 withdraw. So then balance must be what? 8,000. So here balance must be 8,000. Here it is 10,000. I just comment it, okay? Here balance must be, we just deposit only 50,000. Now this must be 10,000 must be minus 2,000, 8,000, and this is 50,000 minus 5,000, 45,000. Let's double check because we again print A1's account number and balance, A2's account number and balance after withdraw. Sorry, this must also be withdraw. Likewise, you can do any of these operations time to time, but of course, these things will be initiated by customers' behaviors. This is just now you can see this is 8,000, 10,000 subtract 2,000, and this is 50,000 subtract 5,000, 45,000. Okay, so that is how you do it. That is how you do it. Okay, right. So that's how we model a class, and then this is how you create. This is your code. Create object, call behaviors. Okay. If you want to even set attributes, right, directly. Now here we set, this is how you read the attribute name. If you want, you can set the attribute as well, A1 dot balance, but that is not a good thing to do, right? Usually your balance must be updated through behaviors. And of course, there are a lot of other theories, like there's something called, now this is called encapsulation. You encapsulate the functionalities of account to a class called account. Encapsulation. This is a class. This is an object of account class. This is you call behavior. So this is called the messaging. Calling behaviors of an object is called messaging. Remember, objects communicate with each other. Not only I can call behavior, even account class call behavior of another object. But we don't go into that level in A-level ICT because this understanding is enough. And also there's something called inheritance. Where one class extend from another class. So then the second class has all the features of the first class, plus it can have additional features. Like say we have, this is a normal account. Maybe we have a super savings account where you can add additional bonus interest. So then you can create another class which extend from this class. So then all these features are there plus additional features. Right. But you don't need to worry about those kind of things, but just aware, right? What is class? What is object? What is attributes? Attributes become your variables like this. Your behaviors are methods or functions. There's a concept called constructor, init, which will be automatically called. Now, if you want to further learn these things, you can have a debug point here. Sorry, you can have a debug point here. Just click somewhere. Remember, we do use debugging in control structures. Then you can say debug. Okay. Now it has come to this position and waiting, right? Waiting for you to interact. Still, it's not getting debug. Right. So now only it's started debugging. Right. So now I can say step in. If you want to see what happens when this line is executed, step in. Okay, this one, step into. Now you can see you are inside the init method. Init getting init. That is why we say it's a magic method. It's automatically called when your object is created. Now the account number is set. Balance is set. Now you can see account number is set. Still the balance is not set because now only it will be executed. Okay. Right. So likewise, now you can see what now you can see what happens here. Again, it will step into the right, initializing for the second object. Now you can see two objects. A1 account number is AC001, balance is 0. A2 object account number is AC002, balance is 0. This is you are looking at the memory. Then you can see what happens when you do deposit. You can step in again, step in. Now this line is executed where your amount is 10,000. So after this line is executed, for A1, the balance is uh, 10,000. But still my A2 balance is 0 because still I have not called this. Yeah, after this balance will be 50,000. You can see this is 10,000. Now you print these values. You print these values. You can see the console. Now you can see again what happens when you withdraw, step in. Now your balance is reduced by this amount. So this balance is also reduced. Now this is 8,000, right? So this is 45,000 because we reduced 5,000, right? So I don't want, I don't do anything other than this, right? This is just a gentle introduction into uh, what is object-oriented programming, what is a class, what is an object. Like I explained the init method, it is automatically called when object is created like this. And this is how you interact with your objects. You can refer to the attributes or you can call behaviors. Okay, so behavior is called messaging in object orientation. And so that is the minimum essential, right? I don't want to add anything additional things, just the minimum essential. Because as I told you, we are not going to learn object oriented programming. No, we are just going to use some existing classes in Python. That's it. So therefore, you will see this dot notation. This dot notation when we are using collections and also calling this dot notation for attributes and dot notation for calling behavior. So this is accessing attribute. This is calling behavior. So basically, you must be familiar with this notation. Otherwise, you will look at what is this. Because so far we have not done this something like this. Okay. So this is basically you are working with objects, right? Objects. Right. Any questions? Right. Because we are done with object-oriented programming. Okay. It's just the ABC of object-oriented programming, right? Nothing serious. Right. So now we can move on to collection framework. Right. So now we move on to our next subtopic, to the biggest subtopic. And most of the time MCQs are related to this subtopic because basically other topics are easy. This is a topic where a little bit of confusion. Actually, this is one of the confusing. I keep telling that Python is one of the simplest programming language. I I highly recommend. I appreciate Python for simplicity, right? But one of the area, actually, it's not problem of Python. Basically, one of the area that the examiners can exploit is data structures. Simply because it has two indices to access these values. So that is not something wrong with Python actually. Uh, because of this, the examiners can create complex questions, unfortunately, right? So the examiners try to exploit it, okay? Right. Right. So what is a composite data structure and why do we need it? Right. So far, if you forget about the object-oriented part, we have been keeping data in variables, right? For example, we can say x equal 10, y equal 20, z equal x plus y, print z, and this will print 30, right? And this is a variable. This is a variable. And at a time, variable can keep one data. Or you can say x 12.5, y equal true, or m equal high, different data type, but whatever the, right? This is of course float, this is Boolean, this is string, str, this is int, but whatever the data type is, the data type can be different, but you can have only one value of that type. So in a simple variable like this, you can keep one value at a time. At a time. At different times, yes, different value. Later, I can say x equal 100. So that is how the simple variables behave. But in Python and all the other languages, whether it's Java, C, PHP, we have composite variables. Composite variables, where one variable can keep multiple values at a time. At a time. So here at a time, one value, different time, different value. But if it is a composite variable, you can have multiple value in a single variable at the same time. So that is what we are going to look at under composite data structures. Okay. First of all, you need to understand what is it. Right. So in Python, there are four major composite data structures. What are those? List, tuple, set, and dictionary. So then someone will ask, why do we need four, not just one for composite? Uh, so not only in Python, most of the other programming languages also there are multiple composite data structures. And the reason is then we can pick and choose the best composite data structure for your requirement. Because these data structures, composite data types, have slightly different behaviors. In general, the idea is keeping multiple values, but they can keep different type of values, different behaviors, and so on. Okay. So therefore, you need to understand these four, but those are not big differences. For example, only difference between list and tuple is list you can change your value. Tuple you can't change your value once set. Only that difference. Set you can't have duplicates values, but list you can. Likewise, it's not that difficult. Dictionary is the one that is slightly different from the other three, but these three you can just learn and understand at the same time. Right? So therefore, don't think it's a big thing. Okay. Right. So therefore, let's first look at the list. Okay. So these are the comparison of list, tuple, set, and dictionary. Of course, you will not understand this right now, but you will understand this at the end of this session or the composite structures. Uh, these are some features, and which feature is supported by which composite structure. You can see list support almost everything or everything. But other data structures does not support, actually this should be red, okay? Sorry for that. This should be red because it does not support mutability. Okay. So likewise, small differences are there. Okay. Right. So let's start with list. I will update the note and because there's a you can see here also it's this must be green, right? Sorry, this must be green, right? I have forgotten to make it green. So I fix that and upload it again. Okay. And I will send a message. Right. So let's start with list. List. List is the basic data structure and very widely used. Okay, so let me copy this code so that I can share at the end. Otherwise, I will forget it. I'll call it 09 OP. And this will go to 0, 10. Oh, sorry, 1, 0, 10 corrections. Right. So that I will copy later. Right. So let's move on to our code. I will delete this and I will call this list demo. Okay. List demo. It's 0, 1. That is our first step because we are going to do a lot of examples here. Right. So how do we create a list? How do you create a list and what is a list? So as I already mentioned, list is a composite data structure. In a single variable, you can keep multiple values at the same time. And duplicate elements are allowed. So that means same value can be in multiple places. So you can have 32 times or any number of times. But if you take something like set, you can't do like that, right? And these values can be changed. So later, maybe I can replace 30 with 80. Okay. And also, at any time, we can add new elements and delete these values. So therefore, this is the most flexible collection. You can have the same values more than once. You can update values. You can add values, delete values. Right? So this is the most flexible data structure, composite structure. And this is how you look at it. Because you can keep multiple data, right? It's like something like this, where you can have your data, say 30, 90, 80, 12, 55. And you just need one variable, but you can keep multiple values, right? So then how do you identify these individual? We call them elements of the variable or the list element. This is an element using something called index. 0, 1, 2, 3, 4. This is called index. So therefore, this is x2 if my variable is x, and this is x3, x4, x0, and it's zero base. First element is called zeroth element. Sometimes it can be really confusing, but that is how in all the programming languages, the first element is called zeroth element because these are related to memory locations and memory addresses are zero base. So that is why we call it zero. It's some, but as a practical situations, it can be really confusing for programmers. But once you get used to it, you know that in programming, IT, first element is zero. Okay. So therefore, this is x2, and you use square bracket, not normal bracket. So this is x0, x1, x2, x3, and so on. Okay. And I told you it's a very simple concept, right? Remember, Python is very simple programming language, but to help you programmers, Python has introduced not just one index, two indices. Almost all the other programming languages, just one index, 0, 1, 2, 3. But unfortunately or fortunately, but examiners really love this, you have another index. Last one is called -1, -2, -3, -4, -5, and so on. So that means you can refer to an element using either positive index or negative index. Positive index start with 0 and increment. Negative index start with -1. -1 is your last element. And then -2, -3, and -4. Okay. Actually, this is a real headache because probe examiners like to give questions in negative indices. Okay. That is how they make it a little bit more confusing for you. Okay. Right. How do you create a list? How do you create a list? Just give me 1 minute. Right. So this is how you create a list. It's like another variable, but in square bracket, you can give your data. Zero value, first value, second value, and so on. Though you call it value one, it's a zeroth index, first index, second index, and so on, nth index. And these values can be of different types, but most of the time we will be using same type in practice. But theoretically, yes, this can be 5, this can be 12.5, this can be true, and so on. So these are some examples. Okay, so here of the same type we have used, but here we can see we have even mix up strings, strs, integers, float, and so on. And this is an empty list. No element has been added because remember we can later add elements as well. Right. So that is how you create a list. This is just a variable name. It can be anything valid variable name. Okay. So let's say A, say 10, 25. I will just use one type, 50, 20, 55, and so on. Remember to use square bracket, right? And here also I made a mistake. It must be square bracket. Right. So this is my list. Okay. This is my list. Now, if you want to see the elements, let's see whether we can print it. Remember, we can use print for simple variables. Okay, let's see what happens if I print a. Let's see whether we can do it first. Yes, it prints like that. This is not a string. This is a list. Okay. And if you want to check the type of the my variable a, you can say print type of a. Print the type of a. So we need another bracket. So let's see what is the type of a. Remember, a is a variable, right? It says it's a class list. Now you can see the word class. Remember, in object-oriented programming, we create a class and then create objects. So basically, you have created object of class list. Okay, object of class list. That is why we did the bit of object-oriented programming. Because when you create a list variable, internally it's an object because there's a class called list, but you don't need to say list, right? But internally it's a list object. That is why I say it's a class list. Okay. Even your data types are also classes, right? When you have integer variable, it's a class int. Now you know what is class is. Okay. Right. So now how do you refer to the individual elements? Remember that you have two indices. Either you go for 0, 1, 2, 3 or -1, -2. Okay. So let's print the 0th element. Say my A, again use square bracket, 0th element. And of course the 0th element is what? 0th element is 10. Let's run and see. Yes, 0th element is 10. Say I want to refer to this one. This is 0, 1, 2, 3. So the third element is 0, 1, 2, 3 is 20. Now you can see one variable. You have multiple values. Just one variable rather than having A1, A2, A3 or X, Y, Z. So one variable you can keep multiple values. So that is the idea behind collection or composite data structure. Okay. And if you want an empty list, you can just use this square bracket. Then no element is there. Okay. And remember, you can use negative index also. This is -1, -2, -3. Now, if you want to refer to this either you can say 0, 1, 2, 3, 4. Right. Fourth element. fourth element, which is 55. Or you can say minus one element, because you remember we have two indices, right? Minus one. So that will also tell you 55 because you are referring to the same element. Minus 1, minus 2, minus 3, minus 4, minus 5. Zeroth element is minus 5. Okay. So this will be minus 5 as well. Minus 5. So that will be again 10. Right? So here you will see 10 twice now. Okay. Is it clear? So it's up to you to decide which element you use. Of course, examiners love negative in this index, but software developers, programmers prefer the positive index because we don't want to make our life complicated. Okay. So you can use your index, positive index or negative index. Okay. Either 0, 1, 2, 3 index or minus 1, minus 2, minus 3 index. Okay. So that I already explained. And the other thing is, not only you can refer to just simple one index, you can refer to range of indices. Then what you get is, now remember, this is a list. Okay, this is another thing you need to understand. Now, what is the type of A? It's list. It's list. But what is the type of zeroth element? It's not a list. It's integer because we are referring to the individual type of this type of the A zeroth element. That is class int or class integer. You can say class int because individual element is integer. Okay. But overall A is a list. Okay. And also if you want, you can mix it. Right? For example, let's say I have B list, 12, 18.5, false, high, or nimal. Now this is a very crazy thing, but possible. Now still if I print B, it will print the list with these elements. And if I ask what is the type of, it will say it's a list. It's a class list. And if I ask what is the, say 0, 1, 2, second element. Second element will be false. False. And its type will be bool. Type of that element, okay? Type of that element. Class bool. And so on. If I ask what is the type of 0, 1, 2, 3, it will say str. And so on. So likewise, you need to understand this, right? So your task is understand, right? Not memorize. So the more you understand, smaller the subject, right? The more you memorize without understanding, bigger the subject, bigger the headache, bigger the stress. Right. So either you can use the positive index or negative index. But if you refer to an index which does not exist, for example, here there's no index called say 0, 1, 2, 3, but there's no fourth one, right? There's no fourth one. Say, still I have the third index, which is the data is nimal. no issue. But what happens if I try to access the fourth element? Because there's no fourth element. So the result is runtime you get an error because there's no fourth element for the 0, 1, 2, 3. No fourth one, fifth one, sixth one. There's -1, -2, -3, -4. There's no -5 also, right? But here you must get a error and stop it. It says list index out of range because it's out of the valid range. Error. It's basically error. So therefore I'll comment this because otherwise I can't run this. But you must know that you get that error. You get that error. If you try to run, if you try to refer to an index which is not valid, or it's outside the valid range. So you must know the error name also, list index out of range. So similar error you will get if you try to refer to -1, -2, -3, -4, anything smaller than -4, like -5, -6. Right. So that is you referring to a one index. Now this is where the real fun comes or the real headache comes. Uh, you can have two indices with colon. So that means you extract part of the list. So far we get a int, float, str, boolean value. But when you have this, you are extracting part of the list. So therefore the result is also list. But you take a part of that, copy part of that into your new list. Okay. And remember you can have two indices. First one is your left index. Second one is right index. But there's a funny thing. This is not only for Python, in all the programming language. The first index is inclusive. The second index is exclusive. This is where the things get really uh, terrible. Okay. Right. So you need to remember this. So when we say 1 to 3, right, 1 to 3, so this is your zeroth index. 1, 2, 3, 4, 5. So 1 to 3 means this is inclusive. But this is not inclusive, exclusive. Right index is exclusive. So therefore, it will extract only these two. So it will not include the third one, but it will include the first one. That is how it works. In not only Python, all the other languages, uh, first one is inclusive, second one is exclusive. Therefore, this will be a list having 20 and 30. Okay, right. So let's take an example. I will copy paste this because I'm lazy. Okay, let's call this C. Right, so this will x 0, 1, 2, but not 3. This will include 20 and 30. 20, comma 30. And its type will be list as well. Let's print the type also. Type of this, type of this. And it will be a class list. Right, I have commented this because I get error. Right, but you can see it's a list and my this is 20 and 30. So this is not include 0, 1, 2, 3, but that means 1 to 2. Okay, 1 to 2. And if you want, you can use the negative index. That is where the things are really confusing also. Like this. Remember, this is now minus. Okay, where is -1? Yeah, there's another typing mistake. Okay, sorry for that. I'll fix both these issues. Okay. So because this should be -1. minus 1. Okay. Other things are okay. Minus 1, minus 2, minus 3. Uh, Now I can say just like 1 to 3, I can say this is 1 to 3 means 20 and 30. I can say minus 5 to minus 3. That means this first one is inclusive, second one is exclusive. Again, it will extract this. Whether it's positive or negative, it will always go from smaller to bigger because minus 3 is bigger than minus 5. Okay. So 1 to 3, but 3 is not inclusive. Here minus 3 is not inclusive. Therefore, minus 5 to minus 4. So the same output will be there. Okay. Same output will be there. Minus 5 to minus 3. Minus 1, minus 2, minus 3. This will be this is minus 1. We need one, sorry. If I want these two, minus 1, minus 2, minus 3, minus 4, minus 5. Uh, so minus 5 is not inclusive. Sorry, the first one is, sorry, minus 3 to minus 5. Sorry, okay. Sorry. Minus 1, minus 2, minus 3, minus 4, minus 5. That is 20. But minus 3 is not inclusive. Therefore, only minus 5 and minus 4 will be taken. So 20 and 30 will be. Because this is minus 3. Minus 3 is, second one is exclusive. So the output will be exactly the same as previous. Okay, 20 and 30. Yeah, I'll again explain. Because this is where the examiners really make you confuse and try to give, not to give marks. So this is 0, 0, 1, 2, 3, 4, 5. Here it's 1 to 3 means 1 and 2. Second one is exclusive. Or you can say minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. So minus 5 is this, minus 3 is this, but minus 3 is exclusive. Therefore, again, you get 20 and 30. 20 and 30. Right. Is it clear? So that means you can extract not only the individual value, you can extract sublist. Sublist. Okay. And I told you examiners can oppose. We don't do this kind of stupid things, but examiners really love giving a questions using stupid things. That means if you want, you can mix negative and positive indices. For example, you can say uh, extract something like 1 to, of course, 1 to 3 is same. Say 1 to minus 2. What is that? 1 to minus 2. So that means, remember, second one is uh, exclusive. So that will extract these three, right? 20, 30, and 40. Always the second index must be right of that. If it is a negative value, it will look at the negative index. If it is a positive value, it will look at the positive index. But definitely your right index must be right of that, right of the first index. Positive or negative, we don't care. Okay. So therefore, if you try to print, okay, let's do this 10 to 60. And I'll be using the same thing. Now look at the very tricky scenarios, okay? So I want to print, say, this to this. That is 0, 1, 2, 3, 4. 1 to 4. Even the second one is exclusive. So 1 is 20, 30, 40. That is 1, 2, 3. 4 is exclusive. Therefore, 50 will not be print. Sorry, I forget about the list. Okay, so now only it will work. Right, so now it should work. C1, sorry, 1 colon to 4. Right, so this will print 20, 30, and 40. But if I try to print it in other way, 4 to 1, that means my second index is in the left hand. So that will print nothing because it always go from left to right. So already you have passed 1. It will only go if it is in the right side. So therefore this will print empty because it doesn't it when in the right side of the 4 you don't have 1. You don't have 1. Okay. So that is why it's simply print like that. So this is again 0, 1, 2, 3, 4, 5. -1, -2, -3, -4, -5, -6. But if you have something like 1 and -2, it will. Because -2 is in the right side. Say 1 to -2. That is perfect. Right? So 1 is 20, -2 is 50, but 50 is exclusive. Therefore, it will be 20, 30, 40. 20, 30, 40. Okay. That is 1, 2, 3. 3 is -3 also, but it won't print the -2 because its second one is exclusive. So 20, 30, 40. Okay. But again, if you say something like, uh, say 4 and -1, that will print only 50. But if you say 3 and -5, because -5 is in the left side, it will again empty because -5 is in the left side of 3. Okay. Say 3 and -5. It is empty. It is empty. Okay. And similarly, if you say -2 and -4, it's still empty because -4 is in the right side, left side. -4 and -2 is fine, but not -2 and -4. So this will be definitely empty. Okay. Sorry, not int, it must be print. And it's my typing mistake. So this will be again empty because -2 is in the left side of -4. So always your second index must be right side of the first index. Otherwise, it will not give error. It will give you an empty list. And if you ask what is the type of this, still it will be an empty list. Okay, because still it's a list, but empty list. It's an empty list. Because it can't find any values. Because it only look at the right side from the first one. And also the second index is exclusive, first index is inclusive. You can mix positive and negative. Right? And is it clear? So I told you this is where the examiner can really check whether you have that solid understanding. Basically, you know your subject? Okay, you can't just guess it. So the right index must be right of the left index. So rather than first index, next last index, better thing is left index, right index. So if your right index is not right of the left index, it will result in empty list. Okay. Right. From this point onwards, we will discuss in the next class. Okay. So still we have not done even 25%. But next class we can finish good part of this. So maybe next class we can fully finish this. I don't think next class we can fully finish this because this is a big topic. This is examiner's favorite. So therefore we'll do it slowly. Okay. Because once this is done, it's file handling is 1 day. Database handling is also pretty much 1 day. Okay. And we stop at this point, right? Thank you.